In this session, we'll try to focus on how we look at the time series data, and especially if I have to plot a graph corresponding to the time series data, what is that we typically end up doing? So whenever I am talking about a time series data, we are talking about the data that is collected across time, probably the sales of a company. Across time means I can collect the monthly sales, or I can talk about quarterly sales or yearly sales, whatever it is. Or similarly, stock prices. I can talk about the daily stock price or monthly average or some such kind of stuff. So you can think of, right, some targets, daily target, monthly target. So wherever my objective is to visualize the trend, how it is changing from one period to the other, as well as seasonality. Probably it might so happen that in a few months or quarters, the sales could be abnormally higher, and in a few months or quarters, the sales could be much lesser. So, if I really want to understand or observe that kind of a pattern in my data, what is that I need to do? So, this is what is the scope of time series analysis. I am looking at the trend as well as the seasonality in the data, whichever is collected over time. Now, probably if I look at the data set, I am using a data set called catalog. If I look at this data set, okay, so this is collecting the monthly sales data right from 2001 Jan till December 2014. Over a 10-year period, the data has been captured. What is that data? The sale of men's clothing, right? Some thousands of dollars or whatever it is. So the sale of men's clothing, the sales of women's clothing, the sale of jewelry by that particular mall. These all will ignore for the time being. So these are the three things that are present. The sale of men's clothing, the women's clothing and jewelry. Now I want to come out with some kind of a plot for that. Right? Now one way to look at is I could have simply put a serial number, right? 120 kind of stuff, right? A serial number kind of thing could be there, and I could do a simple plotting. Probably let me do that as a first step. If I put a simple serial number, okay, I will put, I'll copy it from a spreadsheet. Now I have copied the serial number from the spreadsheet. Let me call this as serial number only. So I have copied it from the spreadsheet. So one way of looking at is I'll plot a scatter plot between this and the sales of men. That's one way I can do, which is a plain scatter plot. Or I may look at bringing in the checking out for the seasonality in it by doing a small alteration to it. We'll try to look at it. So the time series data often shows a trend. Now let's look at that. Probably if I am doing a simple scatter plot, right? So I'll go into this graph template chooser, wherein I'll choose, okay, serial number. First of all, I need to choose it as a scale variable. So once I choose that, I can very well go into my graph. I'll take a graph between the serial number and let's say the sale of men's clothing. Between these two, it says that I can very well go with a scatter plot. And when I'm going with the scatter plot, I'm taking the x-axis as the serial number and the y-axis as the sale of men's clothing. Now the graph is giving me, it's almost a kind of, okay, some kind of U kind of shapes are there. Instead of a straight line pattern, it is showing that for some periods, the values are much higher kind of stuff. So a typical scatter plot is giving me something like this. Or probably even if I am depending on the line chart, right, for the same sale of men's clothing, I can actually go with a kind of a sequence, kind of a line chart also. So when I'm looking at these two also, it is talking about a line chart wherein I can very well look at, on the x-axis I'll take the serial number, and on the y-axis I'll put the sale of men's clothing. So wherein it's giving me a line chart which is also showing, okay, one, there is an uppish trend, but at some point there is some peaking that is happening. Now I need to really identify that dimension, right? So the trend which is coming out is telling me that overall there is an increasing trend. The sale of the men's clothing is increasing year over year. So that is coming out on an overall perspective. But what I am also interested in is this fluctuations that are coming up probably on a monthly basis or whatever. So that is one thing which I have to understand. Okay. In some cases, the trend could be linear growing, whereas in some cases it could be non-linear, wherein especially I see that the growth rates are either increasing or decreasing, or in some cases some kind of an exponential kind of a pattern can come up. Now in this the data file which we are using, the catalog based data file, our goal is to understand the company sales for that men's clothing or whatever it is, and if they are varying from quarter to quarter or probably month to month, and what is the rate at which they are growing. So this information, if I am able to bring out, it can definitely help me to forecast the future sales performance quite effectively. Now for that, what is that I can do? It should help me not just identifying the trend, it should also give me some kind of a picture regarding the seasonality. So I can go for seasonal identification on a monthly basis or a quarterly basis. And that seasonality can be more and more easily predicted when I look at regular patterns in my data. But if the regular pattern does not come up, identifying the seasonality is a very difficult part. So probably in this data itself, what I would like to do is, in that same graph template builder, between these two, what I would like to do is, I want to do the coloring based on the date. Instead of serial number, probably I want to do the coloring based on the month. Different months, I want them to be observed differently. Now, this is where one advantage comes out for us. Either with a line chart, right? For a line chart, probably for different months, we are getting a different lines. Or probably I should look at that with a, I should look at it with a scatter plot also. So let me go with not the line chart, let me go with the scatter plot, wherein the differentiation I would do with respect to the months, right? The differentiation I would do with respect to the months. Fine, I think I should be able to do this. Now you see, yes, there is a color, let's say this one is actually showing up on the higher side across. Right, now that we have so many months, slightly it would be difficult, but what we could see is, if we are looking at it on a quarterly basis or something, this becomes more and more handy for us. right? Probably if this is the one, I can even think of increasing the size. If we try to increase the size, probably a little bit of more clarity does come to the picture. Okay, now what we are able to see is this light violet kind of a color which is observed across, or if possible what I can very well do is in this graph I can also get the namings as well. The data label also I can get the month part. So that can simplify our understanding much more. Okay, I could see that all the 12s are much higher. So which means I could make out that in December I generally am going to see, in December I'm going to see that the sales are going to be much above the typical average, and on an average there is going to be an increasing pattern, but in December the sales are going to be tremendously higher year over year for the male's clothing. So this kind of seasonal kind of a variation can very well be brought out by using this time series kind of pattern. But of course, if the seasonality is becoming more and more complex, if the seasonality is not observed year after year continuously, then it becomes a difficult thing to assess the seasonality. But any time series data, generally we would be assessing it both for the seasonality as well as for the trend, so that we can bring out interesting patterns which can help in forecasting the data much more effectively. So from the modeling standpoint, we need more and more years of the data, especially if the patterns are not that evident. If the patterns are not that evident, if I have to establish appropriate relationships, especially sometimes what happens is some events are very rare, though they are seasonal, probably they occur only once in 5 years. That kind of a data we are calling as the cyclical data. I don't call it as a seasonal data. Probably the business cycles or some other kind of a cyclical data which can happen only once in a while. In those cases, if I have to model that kind of a data, the kind of data, the kind of time periods for which I require the data would be much longer. So always it's better to go with a scatter plot of time versus the sales to see if there is any kind of what is the kind of noise that is coming up as we have seen here, and if that's the case, is the noise more or less random? If I look at it, this is the kind of a straight line, but if I look at the noise around it, probably the 12 is very much on the higher side of the noise, and probably on the downward side, if I see I'm not able to trace anything that significantly on the downward side, probably the 2 could be traced to some extent, right? 2 is getting traced, many 2s are getting traced almost on the lower side itself, whereas almost, so I can very well, just from the figure I should be able to see that December looks like a very effective month with respect to the sales, whereas looks like February is one of the weakest months with respect to the sales. So some such kind of analysis can be brought out, which means there is a definite presence of seasonality in the data. Of course, without the graph, even with a few other things also, we can very well analyze the presence of seasonality, wherein I can go into the analyze forecasting options and I can do a seasonal decomposition of the data. That's a different way. I'll do a seasonal decomposition of this male data, right? Once I do a seasonal decomposition of the male data, I'm getting a few more. Okay, you see a seasonal factor 95.2%. 84 is for February, which is showing on the lower side. 179 is for December, which is coming out on the higher side. So I could, even from this data, I could make out that probably December is a month where the sales are extraordinarily higher, but February could be a month where the sales are exceptionally lower. Even this data format can give us the same kind of a picture, but in some cases the graphical way where I am looking at the noise and evaluating the contributors of the noise from the scatter plot itself. So just the basic understanding of the time series data, what kind of graphs I plot for the time series data is very much necessary for us to understand. How I differentiate the time series data from the other data forms is also something which we really need to look at, right?